Rates. What's your problem? A 25-foot ladder is leaning against a vertical wall. The floor is slightly slippery and the foot of the ladder slips away from the wall at the rate of 0.2 inches per second. How fast is the top of the ladder sliding down the wall when the top is 20 feet above the floor? Step 1. Understand what's being asked. Read the problem carefully and identify all the quantities that are changing. We are given that the ladder is 25 feet long, it's slipping away from the wall at a rate of 0.2 inches per second, dx dt, and the top of the ladder will be 20 feet above the floor, y. We want to find the rate at which the ladder is sliding down the wall at the specific height, dy dt. Step 2. Find the value of x. Use appropriate variables to represent the quantities involved in the problem. Write down all equations that relate these variables and other constants. These equations might involve area or volume formulas, like Pythagorean theorem, or similar triangles from geometry. In our case, x will represent the floor and y will represent the wall. Through the relationship between the wall, the floor, and the ladder, we see that it forms a triangle. And the formula that relates all three is the Pythagorean theorem, and we get that x squared plus y squared equals 25 squared. Plugging in the given variables, we solve for x, and we get that x is equal to 15 feet. Step 3. Differentiating the equation. Assume that all the variables in this equation are functions of time, usually given implicitly, and differentiate both sides of the equation with respect to time t. In other words, d over dt. This usually involves implicit differentiation. In this case, it definitely involves implicit differentiation. But first, since we are missing a key variable, we must solve for it. In our problem, we are missing the value of x, the distance between the bottom of the ladder and the wall, when y, the height of the wall where the ladder is leaning, is equal to 20 feet. From the previous step, we know that when the ladder is leaning on the wall 20 feet from the ground, the ladder is 15 feet away from the wall. Now, in order to find the rate at which the ladder is sliding down the wall, dy dt, we must derive the equation x squared plus y squared equals 25 implicitly, and we get 2x dx dt plus 2y dy dt equals 0. Step 4. Solve for dy dt. In the resulting related rate equation, substitute the given numerical quantities and rates. Remember that a rate of change of a quantity is a positive number if that quantity is increasing, and is a negative number if that quantity is decreasing. Then solve for the unknown rate of change. Be sure to include the appropriate units of measurement with your answer. We substitute all our known variables and solve for dy dt. Then we find that the rate at which the top of the ladder is sliding down the wall when the top is 20 feet above the floor is 0.15 inches per second.